Hello everyone, now this is Dolphin Data Lab Technical Support Team, and today let's check one new case about the Seagate 5000DM000, and this is one new hard drive we just received in our data recovery lab. And let's try to power on this hard drive and check what kind of terminal messages output in the COM terminal. And we try to Ctrl Z to enter F3T and Ctrl L, and we can find out this diagnostic port locked. If we want access to the firmware error and fix the firmware corruption, and we must unlock this COM port. Now we try to enter the program. We can skip this because right now and it tries to read the firmware, but the firmware is locked, so sometimes it takes a longer time to be fully initialized here. After we escape this interface and we come here, and the very first thing to fix this hard drive is to back up the ROM. Now we need to pay attention to the firmware structure. When we try to back up the ROM, we need to use this structure, and then we try to read. Now the hard drive is entering the boot mode and then reading the ROM. We have just selected a high baud rate to back up the ROM. Now we can see the ROM backup parse. ROM read OK. Next, we need to generate unlock ROM. So we select this arrange ROM, and this is unlock ROM. Then we click save, click OK. We can see its operation success. So for users, it's very important to read the log window and find out what is happening with the pension hard drive, and then users will have a clear mind on how to continue the repair. Next, we need to write as unlock ROM without short. Now we write this unlock ROM here. You can see this is a parse, unlock ROM parse, and the program is now writing this unlock ROM. We can see this pension hard drive has 8 heads, so 4 platters, and it's 4K hard drive. Firmware locked, and no modules are available here. Now we just need to wait until the unlock ROM is written to this pension hard drive. Now from the lock window, we can see the ROM write OK. So after writing the unlock ROM successfully, users need to power off and power on the hard drive, and then we can check in the COM terminal. Here we check this tech unlock handshake value, then we need to send the unlock key. Now we try to use Ctrl L, so we can see this hard drive has been unlocked successfully. Now we can see the product ID, the family ID, and this is the family name, the head type. Now we can input any commands to repair the firmware corruptions. Anyway, before we doing any firmware repair, and it's the best, users backup the most important as well as files. Now we can see it's LED by this way. So when we try to back up the SOS files and we see the pension drive get busy and it becomes LED, so at this time what to do next? Now we can see it's LED now. So we must power off and power on the drive again and wait and send unlock key. Now we try to read as well as in COM mode and see if it is possible to get the SOS map. Now by COM we get this map and then we try to read the important SOS file. Now we can see it is possible to read, but right now it is very slow by this way. So we can click stop, and here we try to enhance the baud rate. Now we select a higher baud rate. Maybe this one is not supported here. Come back. We check this most stable baud rate. Now we can see it works, and then we go to read the SOS files. Usually we just need to back up the 35, that is enough. Now let's try to back up this one. Now we can find out the backup is much faster now. So users just check the log window. If the ATA backup of the SYS files failed, so users can try the SYS file backup by the COM mode. If both ATA and COM mode backup failed, from this menu, read SYS file, then we try to use the edit SYS files, and then we input the SYS file ID and volume and backup them manually. So we have many different methods to backup the important SYS files. So sometimes when the drive is very unstable, so users don't need to back up all the SYS files. The most important one is the ng list. That's the SYS35. For most of these SED-locked hard drives, it is possible after unlock to backup the firmware modules in AT mode. Then the backup will be much faster. By COM mode, so users need to have a little bit patience. Now 70%. Now it's 90%. After this one, it is easy to fix the firmware corruption. Now we just need to wait a little bit more time, then we can fix this hard drive. Now we can see this Nginx has been backed up successfully. Then we go to the COM terminal and try to check the glist. So there are some bad sectors inside, some defects. So we need to clear them and check again. How about the V4 0? The entries are 0. Then we try to use the M command to regenerate the translator. Now we need to wait until the translator regeneration completes. This translator regeneration takes a little longer time than the normal F3 hard drives. Sometimes before we run this M command to regenerate the translator, we go to the defects management, initialize ID, and try to edit the settings inside, and then we run this command, and it can be better result in some cases. Now we can see the translator regeneration completes. So at this time, we try to check this one and see if the program can read it. Failed. So we try the COM and see if the COM mode works or not. Now, so we can forget about this one, and we can try to status refresh, get all. The program is refreshing the hard drive. You can try to power off and power on the drive. Now we try to scan the hard drive and check the result. Okay, so this hard drive is good now, and let's check the ending part to see if the data error in the ending part is accessible or not. Now we can see it has some issue in the ending part. So now this drive, it's partial sector access issue. Because in the beginning, it is accessible, but from some certain point of LBA, it becomes unaccessible. So we need to enter the program. We need to power off, power on, unlock the drive. We can try to re-enter the program. Now, after the unlock, we can see the modules are available here. Now, let's go to the ATA mode and try to write the SYS files. So 35. We can write by SYS mode. Writing success. We can check the V4, V4 0, and then we try to regenerate. The translator again and see what will happen with this hard drive. So we can see now after we writing back the SYS file, the entries are 5 in the entry list. So we need to regenerate the translator and see if the entries remained or not. Now the translator regeneration completes. We need to check the engine list again. It becomes 0. Right now we try to access to the data arrow and see. Now we can see the data array is accessible fully. That means this drive has been 100% recovered. So we just writing back the original SYS35, the engine list, then regenerate the translator again, and we can see all the data arrows are now accessible. So by above method, we have unlocked this hard drive firmware error, and we fix the firmware corruption, and then we fix the partial sector access problem, and finally we get all the lost data back. Now users just need to go to the DFL DDP data recovery program and recover the lost data. Thank you for watching this video.